Hi, I'm Patrick Reagan. This video continues the previous video of troubleshooting wireless issues. With this video, part 6, troubleshoot common wireless issues with a focus on wireless interference, channel overlap, signal degradation or loss, insufficient wireless coverage, client disassociation issues, and roaming misconfigurations. Similar to wired networks, there's a limited amount of frequencies or channels and an increasing number of wireless devices. Not everyone can talk at the same time. Even nearby access points that use the same frequencies can cause interference. Most access points can monitor frequency usage and automatically move devices to unused space. One important reason to choose newer equipment that supports the 5 GHz frequency band is that the signals on the band have a shorter range and are therefore less likely to create and pick up interference from networks running on older equipment that uses the 2.4 GHz band. Other devices may cause interference because they use the same frequencies are separate wireless networks in your own home, next door, or in nearby offices, Bluetooth, baby monitors, walkie-talkies and other radios, cordless phones, microwave ovens, outdoor microwave links, fluorescent lights, and WiMAX. Also, obstacles can stop radio waves or reduce the reach of radio waves. You should disable 802.11b and or disable legacy rates 1, 2, 5.5, and 11 megabits per second on new access points because it's an outdated wireless standard with significantly slower speeds compared to the newer protocols like the 802.11g and 802.11n. Because of 802.11b offers significantly lower data rates compared to newer standards, 802.11b devices on faster access points impact network performance for all users. In addition, older devices that are made for the 802.11b may have outdated security features, making the network more vulnerable to attacks. Since most modern devices no longer support 802.11b, so disabling has a minimum impact on device connectivity. Channel overlap occurs when multiple networks are using channels that partially or fully overlap with each other, leading to interference between the signals, causing reduced network performance, slower speeds, and potential connection drops for devices on those overlapping channels. Essentially, it's like trying to have multiple conversations on the same phone line at once, causing garbled audio. When signals from different networks on overlapping channels mix, they can disrupt each other's data transmissions, resulting in packet loss and slower speeds. Adjacent channel interference, or ACI, is a specific type of interference where channels that are close to each other on the frequency spectrum cause issues, even if they don't completely overlap. Channel overlap can significantly impact network performance, especially in densely populated areas with many Wi-Fi networks operating on the same frequency band. To avoid channel overlap, choose non-overlapping channels. In the 2.4 GHz band, channels 1, 6, and 11 are generally considered the best choices as they have minimum overlap. Use a wireless site survey tool that will help you analyze your environment to identify the best channels with the least interference. The Wi-Fi scanner tool on your computer or smartphone will display the channels used by nearby networks, allowing you to identify if multiple access points are set to channels that overlap with each other. Adjust channel settings on your router by manually selecting a channel for your network. Consider splitting the network with newer technologies that has additional frequencies by adding additional access points. Adjust the outpoint power to help avoid conflicts with other access points. When creating a wireless infrastructure, you will need to check to see if you have sufficient wireless coverage. To check for insufficient wireless coverage in a network, physically walk around your area with a connected device, observing the signal strength indicator on your device, usually represented by bars, while noting any significant drops or dead zones. You can also use dedicated Wi-Fi analysis apps to get more detailed information about signal strength, channel interference, and coverage maps across your space. Download a Wi-Fi analysis app on your phone or laptop, such as Wi-Fi Analyzer or NetSpot. Test with different devices to ensure the issue isn't isolated to one device. Check signal strength on different floors and in various rooms within your building. Look for potential sources of interference like microwaves, cordless phones, and other Wi-Fi networks operating on the same channel. Plan for ongoing site surveys since things will certainly change. Generate a heat map to identify wireless signal strengths. A heat map for wireless networks is a graphical representation of signal strength or coverage areas within a specific area. It visually displays the strength and quality of the wireless signals, usually using colors to indicate signal strength. It is used to ensure proper signal strength in a wireless infrastructure and optimize the placement of wireless access points. If you find that you have insufficient wireless coverage, try the following. Reposition your access point. Try placing your router in a central location away from obstacles. Adjust router settings by changing the Wi-Fi channel to a less crowded one. Upgrade your router with more powerful antennas or a newer Wi-Fi standard. Add a Wi-Fi extender to boost signals in weak areas. And for larger areas, consider a mesh network system to provide more even coverage. A jamming attack is a type of cyber attack aimed at disrupting or interfering with wireless communication signals such as Wi-Fi, Bluetooth, or cellular signals. The goal of a jamming attack is to prevent legitimate users from accessing or using the wireless network by flooding the airwaves with noise or interfering signals. The attacker broadcasts noise or fake signals on the same frequency band as the target network. This interference disrupts the normal communications between devices and access points. By overwhelming the target network with interference, the attacker causes a denial of service or DOS condition. In many cases, the attacker needs to be physically close to the target network to launch a jamming attacks effectively. However, with more powerful equipment, attackers can launch attacks from a distance. Jamming attacks can be launched using various methods and tools, including specialized jamming devices, software-defined radios, or even modified consumer electronics. These attacks can be particularly disruptive in critical environments such as military communications, emergency services, or industrial control systems. Defense against jamming attacks often involves techniques such as frequency hopping, spread spectrum modulation, signal filtering, and the use of directional antennas. Additional encryption and authentication mechanisms can help mitigate the impact of jamming attacks by ensuring the communication remains secure even in the presence of interference. Signal attenuation refers to the gradual weakening or loss of signal strength as it travels through the transmission medium, like a cable or wireless connection, resulting in reduced signal amplitude at the receiving end. Essentially, it means the signal gets weaker over distance due to factors like resistance and interference, and it's usually measured in decibels. It can also be reduced or blocked by obstacles including walls and furniture. Poor quality cable can also cause signal attenuation. The attenuation can be measured with a Wi-Fi analyzer. To combat signal degradation, position your router in the center of your home or building to evenly distribute the signal. Place the router off the floor and away from obstacles like furniture or walls. Use your router settings to identify and choose a less crowded wireless channel. Adjust the channel bandwidth depending on your needs and interference levels. For targeted signal or coverage, use directional antennas to focus the signal in specific areas. Adjust antenna position on your router to maximize signal strength. Keep other wireless devices like microwave ovens and cordless phones away from your router. Manage Bluetooth device usage near your router to minimize interference. Use a wireless repeater to extend the range of your network in areas with weak signal. Consider upgrading your router to a newer model with better signal strength and range capabilities. Regularly update your router's firmware to benefit from bug fixes and performance improvements. And adjust the transmitter power level on your router to optimize signal strength. In a wireless network, client disassociation refers to the process where a wireless device or client actively disconnects itself from an access point, essentially ending its connection to the network. This can happen naturally when a device moves out of range, is powered off, or is intentionally disconnected by the user, and is signaled by a disassociation frame sent from the client to the access point. Key points about client dissociation is, as part of the device normal behavior, when the device wants to leave a wireless network, it sends a disassociation frame to the AP, notifying it to remove the client from its association table. Reasons for dissociation include device moving out of range, device powering off, user manually disconnecting, switching to a different network, or network issues causing unstable connection. Malicious actors can exploit the dissociation process by sending fake disassociation frames to disrupt connections between clients in the AP, causing devices to repeatedly disconnect and reconnect, essentially creating a denial of service attack. To deal with client disassociation on a wireless network, you should first identify the root cause by analyzing network logs and signal strength, then adjust settings like channel selection, power levels, roaming aggressiveness, and client device drivers, ensuring proper AP placement and considering factors like interference and load balancing. If the issue persists, investigate potential hardware problems or malicious activity and implement security measures to mitigate attacks. Key steps to troubleshoot client dissociation include 1. Identify the issue. Monitor network logs. Monitor network logs by checking access point logs for frequent disassociation events, noting the reason codes and affected clients. Signal strength analysis, which uses a wireless site survey tool to check signal strength around the network, identifying areas with weak signal that might cause disconnections. And client device analysis, which checks if an issue is specific to a certain client device or operating system. 2. Configuration adjustments, including optimize channel usage by avoiding heavily congested channels and using automatic channel selection if available. Adjust power levels on access points to ensure good coverage without excessive signal overlap. Adjust roaming settings to balance seamless handoff between access points with unnecessary roaming events. Review dynamic channel allocation or DCA settings to ensure appropriate channel changes based on the network conditions. And properly configure load balancing to distribute clients evenly across access points. 3. Client device management, including ensure client devices have the latest wireless network drivers and verify the client device settings like power saving modes and roaming settings. 4. Network infrastructure considerations include ensure access points are strategically placed to provide optimum coverage throughout the network, and identify and address sources of interference like other wireless networks, microwave ovens, or Bluetooth devices. If the problem persists on a specific access point, check for potential hardware faults. And 5. Security measures against malicious dissociation attacks. Use strong encryption standards like WPA2 or WPA3 to prevent unauthorized access and disruption. Implement MAC address filtering to limit access to authorized devices. Continuously monitor network traffic for suspicious activities, including frequent disassociation attempts. A roaming misconfiguration on a wireless network refers to incorrect settings on an access point or network configuration that prevents devices from smoothly transitioning between different APs while moving around, leading to connection drops, slowdowns, or inability to maintain a stable connection as the signal strength changes. These wireless networks often has a single name or SSID and appears as one big wireless network. There might be multiple access points supporting an SSID. Some symptoms of roaming misconfiguration include frequent connection drops as devices disconnect from a network while moving between APs due to poor signal handoff. Increased delay during the transition between APs, impacting performance for activities like streaming or online gaming. Devices might be stuck on a weak signal AP for too long before switching to a stronger one. Some causes of roaming misconfiguration include Issues like mismatched signal strength, thresholds, poor AP placement causing gaps in coverage, or inconsistent power levels between APs can disrupt roaming. Make sure you enable the roaming protocols like 802.11k, 802.11v, and 802.11r, which facilitate seamless handoffs between APs. Older devices might not support advanced roaming features, causing issues with newer networks. Configuring settings to switch APs too frequently, even with a decent signal strength, leading to unnecessary connection disruptions. Access points don't have identical configurations. How to troubleshoot roaming issues include check signal strength thresholds, channel allocation, and ensure all APs are configured consistently. Ensure proper coverage throughout the network by strategically positioning APs to minimize dead zones. Verify that 802.11k, 802.11v, and 802.11r are enabled on both the APs and the client devices. Use tools to analyze signal strength and identify areas with poor roaming behavior. Keep AP and client device firmware up to date to benefit from the latest roaming improvements. A good received signal strength indicator, or RSSI value, for Wi-Fi is generally considered to be negative 30 decibels to negative 70 decibels. The value is negative because it indicates how much loss of signal compared to a known reference power, usually 1 milliwatt. Values above negative 70 decibels may indicate a weak signal, especially for high demand tasks. A general recommended RSSI threshold for wireless access points is between minus 70 decibels to minus 80 decibels. The RSSI threshold is a minimum signal strength level that a wireless device like a Wi-Fi router or access point requires to maintain a connection or allow a device to associate with it. When a device's RSSI falls below the configured threshold, the device may either disconnect or roam to a stronger signal from another access point. This threshold helps ensure reliable connectivity and reduces roaming issues by preventing devices with very weak signals from connecting. In Windows, roaming aggressiveness in your network adapter settings refers to how frequently your computer will search for and switch to a new, stronger Wi-Fi signal from an access point. Higher aggressiveness means that the computer will switch more often, potentially improving connectivity in environments with multiple overlapping networks. Settings include lowest, where the device is less likely to roam and will stay connected to the current AP even with a weak signal. Medium, a balance between staying connected and finding a better signal. And highest, where the device will actively search for and switch to a stronger signal even if the current connection is still relatively strong. To troubleshoot captive portal problems, start by ensuring a strong network connection and try common fixes like restarting your device or clearing browser cache. The login page doesn't appear automatically. You can try opening a new browser window, accessing a non-HTTPS page, or try a different browser. For persistent issues, consider disabling VPNs or checking access point or router firmware. If you appear to connect with ease and you get disconnected often, but connection is restored when you disconnect and reconnect the captive portal session, check the captive portal session timeout settings, which may be misconfigured or may need to be increased. Other common problems with wireless networks include wireless networks are inherently more vulnerable to unauthorized access due to the open nature of the airwaves. When multiple devices are connected to the same network and using high bandwidth applications, it can cause slowdowns and buffering. Faulty antennas, outdated routers or access points, or poorly positioned access points can affect signal quality. Lastly, incorrect settings on the router or access point can lead to connectivity issues and security risks. Question: a small office has a wireless network with several access points that are used by mobile devices. Users occasionally report that the wireless connection drops or becomes very slow. Reports confirm that this only happens when the devices are connected to the office wireless network. Which of the following is most likely the cause? Answer: interference from other devices. Question: a network technician is troubleshooting an area where the wireless connection to devices is poor. The technician theorizes that the signal to noise ratio in the area is causing the issue. Which of the following should the technician do next? Answer: remove any electronics that might be causing interference. Several Wi Fi users are reporting the inability to connect to the network. Wireless LAN users on the guest network are able to access all network resources without any performance issues. The following table summarizes the findings after a site survey of the area in question. Which of the following should a wireless technician do next to troubleshoot this issue? Answer: configure the channels to reduce overlap. As you can see from the table, AP1 and 2 are using channels 1 and 2, which overlap, which is supported by larger loss of signal as indicated by the RSSI. Question: a network consultant needs to decide between running an Ethernet uplink or using the built-in 5 GHz point-to-point functionality on a wireless access point. Which of the following documents provides the best information to assist the consultant with this decision? Answer: site survey results. Question: wireless users are reporting intermittent internet connectivity. Connectivity is restored when the users disconnect and reconnect, utilizing the web authentication process each time. The network administrator can see the devices connected to the APs at all times. Which of the following steps will most likely determine the cause of the issue? Answer: verify the session timeout configurations on the captive portal. Question: a network administrator redesigned the positioning of the APs to create adjacent areas of wireless coverage. After project validation, some users still report poor connectivity when the devices maintain an association to a distance AP. Which of the following should the network administrator check first? Answer: validate the roaming settings on the access points and wireless LAN clients. Question: a network administrator determines that even when optimal wireless coverage is configured, the network users still report constant disconnections. After troubleshooting, the administrator determines that moving from one location to another causes the disconnection. Which of the following settings should provide better network stability? Answer: RSSI roaming threshold. For more information, visit these sites. In summary, one important reason to choose new equipment that supports the 5 GHz frequency band is that the signals on the band have a shorter range and are therefore less likely to create and pick up interference from networks running on older equipment that uses the 2.4 GHz band. Channel overlap occurs when multiple networks are using channels that partially or fully overlap with each other, leading to interference between the signals, causing reduced network performance, slower speeds, and potential connection drops for devices on these overlapping channels. To check for insufficient wireless coverage in a network, physically walk around your area with a connected device, observing the signal strength indicator on your device, usually represented by bars, while noting any significant drops or dead zones. A heat map for wireless network is a graphical representation of signal strength or coverage areas within a specific area. A jamming attack is a type of cyber attack aimed at disrupting or interfering with wireless communication signals such as Wi-Fi, Bluetooth, or cellular signals. Signal attenuation refers to the gradual weakening or loss of signal strength as it travels through a transmission medium, like a cable or wireless connection, resulting in reduced signal amplitude at the receiving end. In a wireless network, client dissociation refers to the process where a wireless device or client actively disconnects itself from an access point, essentially ending its connection to the network. A roaming misconfiguration on a wireless network refers to incorrect settings on an access point or network configuration that prevents devices from smoothly transitioning between different APs while moving around, leading to connection drops, slowdowns, or inability to maintain a stable connection as the signal strength changes. Thank you for watching this video. The next video will be Wireless Networking, Part 7, Cellular Satellites and Towers. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.